Hello, my name is Jonathan, and I'm going to show you today my advanced games programming AI assignment. So the focus that I took on this project was to work on something like a cover system. It's often implemented in games, first-person shooters especially. However, I have no idea how to do such a thing. I didn't actually look up how they do it, but I think the solution I came up with would be the one that is often used. So let's go into how it's done. So the building blocks of the whole system use these cover actors. So the cover actor, in my definition here, is basically an actor that contains pretty much anything, but the main thing is a collection of these cover point components. So what they do is they show where one might be able to take cover around the object in here, which means that I can actually throw any object I want. So as you can see, this is another cover actor, but it actually has 3 cover points, 1, 2, and 3. And it allows designers to easily create new and interesting bits of geometry with cover attached to them and throw them in anywhere in the level, and they should be able to work. Now, what these cover actors provide is that they can, hold a list of all of their cover points, but most interestingly, the cover points can do a raycast within the actor. So this is an actor line trace, and what that will do is it will do a raycast only within components of the actor itself. So it's going to take that cover point location, and maybe the player's over here, and it's going to do a line trace there and say, did I hit anything? And if you did, then it provides cover from whatever you're trying to provide cover from. And that is very useful because then agents in the scene can take one of these cover actors and say, hey, do you provide cover? And then it will return saying, yes, I provide cover. You can go to this specific location in the world, and you will receive cover from me. So that's of benefit, but if we left it there, then it would mean that each AI would have to hold a list of all of these cover points or cover actors in the world, right? So the natural solution there is to come up with something of a cover system. So the cover system is actually held in the game mode because that's kind of like it's like a global singleton. So it means that it will only spawn one into the game at any one time, which is useful, and it will always do it on start. So the way that is done is we have this cover system, which is a U object. The U object gets instantiated by the game mode, and then what it will do is we'll go around and collect all of the cover actors in the scene. So once it has all of the cover actors, it's then going to turn them into nodes, and the nodes are also U objects. They're U objects that contain the actual cover and a bunch of information that you'd see in probably like an A star node. And the reason for this is to actually abstract a lot of that A star information out of the world objects themselves because it's irrelevant. Now, ideally, this would be done with a struct, but unfortunately, as you can see here, Unreal hates pointers being held in structs, so we opted to just go with the U object for that, make sure that it doesn't lose references. And then it will generate a graph. Now, this is the interesting part of the whole deal. So I'll press play, and you can just see what happens. So right there, you can see that a graph was generated, and the reason for that is that it means we can chuck down any cover that we want in the scene, and that will get added to the graph automatically. So we don't actually tell it what the graph looks like, it just kind of works out how it's going to construct this graph. And originally this was done with nearest neighbor, but apparently nearest neighbor will end up with you having a lot of islands, which is not very good when you have something like a pathing system going on. So the method we ended up using was random geometric graph, So random geometric graph is the simplest equation you'll come across. It's just if these two things are within a specified distance known as r, then connect them both ways. So you can see here, this is just increasing the r distance, and the more connected this thing becomes based on how far it can connect them from. So that is a very easy way to automatically generate a graph in a scene. It just means that if we move something outside of the range, we can create islands, but we're much more in control of islands because we can actually say, okay, as long as covers are not more than 10 meters away from each other, they'll all be part of the same graph. So getting back to it, the reason why this cover system is valuable as kind of like part of the game mode singleton is because it means agents can query it for things like find cover path. There we go. And find cover path is something like an A star. And what it'll do is we'll go through each of these nodes and say, okay, well, I can get you from where you are right now to somewhere closer to the player through a network of nodes in the scene. And I will make sure that as many of the nodes that I give back to you provide some sort of cover from the player. So it will then return the actual path to the player. And that can then be used, as we do use it, in our hierarchical finite state machine in the move cover state. So what this will do is it will generate a path basically once alerted is how the finite state machine works. Once alerted, the AI will generate a path towards the player from where they are, and then they will pop off cover locations, check if they're occupied. So that's something I didn't mention about cover points. We actually added a way to lock them by setting occupiers and then releasing occupation once they leave. That way, if we have multiple agents in a scene, they'll never end up using the same cover points. They'll wait patiently, or they will find a different path, which is great. And then it will actually try and move to that location. And in doing so, once it gets close enough to the cover point in question, it will check whether it still provides the cover that they thought it did. If it doesn't, keep moving. If it does, then this flag over here allows us to move states to maybe a state where it hunkers. If it does provide cover, it will hunker down, or it will fire from there, or something like that. Otherwise, it's just going to nullify it and just keep going with the path until it gets to the end and closest to the player. So yeah, let's see how that looks in action. So he's just patrolling, he's patrolling. Oh, he sees me. He's going to get back there behind cover, and now he's going to move to a closer cover point. But I'm probably within fire range, so he's going to fire at me while I'm back here. So let's move a little bit further away from him. And he's going to get himself behind the next piece of cover, but he's not close enough, so he's going to come a little bit closer and move further away. And if he sees me, he's going to shoot and keep getting closer until we're right in each other's face. And there we go. That there would be our cover system for the scene. We can actually add another enemy character there, and you can see that the two of them will both path. You need to grab both of their attentions. Well, you see me, and you see me. And now they're both going to try and get to my location. Anyway, that's all. Thank you.